Hello everyone, welcome back to my channel. Today we have these two HB power supplies. Both are identical power supplies and they both are model PS-4241-9HB. They both are identical. So let's try and fix them both at one video if possible. So the first thing we always do is test them before opening them. So let me connect the power cord. Let's try this one first. Okay, now we are at 60 watt bulb, this one. The power is on, we have 236 volts and let's turn on. Okay, so the power is on and we have nothing at all, so the bulb does not lit at all. That means the primary side of the power supply is faulty actually. The fuse is blown. That's why it's not charging the primary capacitor. So let's test the other one. Okay, let's turn on. Okay, this one is good. The primary side is good. Let's test. I wish you can see the multimeter. I want to test the standby voltage. So the green wire has nothing at all. Okay, so it does not have the standby voltage actually. So this power supply could be easier than this one to repair. Let's disconnect. I will start with this one. Okay, let's leave this aside and let's open this one. Okay, so the power supply is opened. And the standby voltage IC is looking good actually. Let me zoom in so you can see. Okay, so the standby voltage IC is this one over there. Okay, it looks good, it's not blown. So that means it could be the standby voltage, the secondary side of the standby voltage, or this driver IC is not working. It's not shorted. If it was shorted, the fuse will be blown. If that IC was shorted, the fuse will be blown, and that IC almost all of the time it explodes. And maybe one of the diodes next to it also get shorted. So now when we tested it, the primary side was good. This capacitor charged. That means we have no shorts at the primary side, at the mains power supply, SMPS, and the standby power supply. Okay, so let's take the board out and check the secondary side. The secondary side has a diode, which is this one over there. Let me zoom in again so you can see it. It's there. Yeah, this one. So we need to check that diode, if it is shorted or not. So we need to take the board out. Okay, so the board is out. Let's measure this big capacitor, if it does have a charge. It has only 0.8 volt, which is safe to touch. Okay, so let's go to diode mode and check that. Diode, which is this one. And yeah, the diode is actually shorted. So this might be the only problem with this power supply. Let's take the diode out and replace it. Okay, so here is the diode. Let's test it. And yeah, the diode is shorted. Okay, so here is a replacement diode. Let's test it. Okay, 0.3. And then this one is shorted. Let's install it and hope this power supply will work. Okay, if we test now, we don't have short. So let's put it back together and see if it will work. Let's turn on. Okay, we have 237 volts. And the lamp flashed as normal. If we test now from the black to the green, we have 4.3 volts, which is right. So if we put here, we have 11.6 volts at the 12 volt line. No, this is the standby voltage, the purple one, and the yellow one has nothing until we short the wires, the green and black wires. And yeah, it is working. We have 12.2 volts. Yeah, so this power supply is now fixed. Okay, let me put it back together, then we will start with the other one. Okay, so let's test it once more and then we can call it a fix and start with the other power supply. Okay, it's on. Let's short the wires. And yeah, it is working. We have 12.28 volts. Okay, let's start with the other one. And we said that this one does not work at all. If we try it once again, the lamp does not flash at all. And if we measure the voltage at the green wire, we have nothing at all. Okay, so let's open it and see what's wrong with this one. Okay, so the power supply is opened. I cannot see anything wrong with it. So we need to take it apart. Then we can test and start from the bridge rectifier and inside towards the power supply. Let me take the board out. We need to test the fuse first and then test why the fuse got blown. Okay, so the power supply is out. Let's test the big capacitor. And we have 0 volts. Let's go to continuity mode and test the fuse. The fuse is this one. I don't know if you can see it, but it is here, this black part. Okay, it's this one. So let's test it. And the fuse is blown. Okay, let's go to diode mode and test the bridge rectifier, which is here, this one. Okay, so the positive side is here, and at the positive side we bought the negative lead, the black lead, and test the AC side. This is good, and this is good. Both are reading 0.5 voltage drop. Okay, and then at the negative side we bought the red lead and test the AC side with the black lead. They both are good. Now if we test these two, which are the AC side, they are not shorted, and the DC side is shorted. So there could be something shorted after the bridge rectifier, or it could be the bridge rectifier itself. What can I do? I can inject voltage here and check what gets hot. Or I can just take the bridge rectifier and test it out of the circuit. But I think the better thing is, or the better way to go is to inject voltage, I think. Yeah. So let's inject voltage, because we have here the main switching transformers which drive this main SMPS transformer. Then here we have the rectifier diodes at this heatsink, and also at this heatsink at the back side we have the BFC circuit, a diode and a Mosfet which drives this transformer here, the power factor correction circuit. So we need to inject voltage to know what is shorted. Is it the BFC circuit, or is it the main switching transistors, the MOSFETs? So let's inject voltage there and use my thermal camera to see what gets hot. We have 1 amp. Let's raise it to 2 amps. Okay, 2 amps. Okay, so this is the positive side of the bridge rectifier, and this is the negative side. Okay, it's drawing 2 amps. Let's see what is getting hot. I can see this heatsink is getting hot. Yeah, I think it's this, the BFC circuit, I think. The MOSFET is shorted, I think. Let's take this heatsink and see if the short goes away. Okay, so the heatsink is out, finally. Let's test the short now. Do we still have a short? At the bridge rectifier DC side, and we don't have. So the short is actually in this heatsink block. Okay, let's test this BFC circuit first, the diode. The diode is good. The MOSFET, and the MOSFET is actually good. So it is one of these two transistors. Yeah, this one is shorted, and this one is good. Yeah, I can turn it on, and I can turn it off. Let me zoom in a little bit. Okay, so if we test from here to here, it's off right now. It's reading 0.4 voltage drop. As you can see, let's turn it on. I will touch this pin with the positive side, And if now I touch this, it's on, as you can see. To turn it off, we need to touch this pin again with the black lead, and if we test now, we have 0.4. This one is good, but this one is shorted, completely shorted. Let's hope nothing else is shorted. This one is actually this one. Let's test the resistor. So the resistor of this one, the good one, is reading 6.9 volts, and this one reads 1.9K. I don't know if it is correct or not. I need to turn on my microscope. Okay, so this resistor is 202. So yeah, I think this is correct. Let me clean it a little bit. 20 and 20, so it's 2K resistor. And it is reading 2K. It is correct. The other one, which is this one, is 103. And it reads 6.9 ohms. There is a resistor here and a jumper. So from this side of this resistor, it goes to the resistor, and from this side of this resistor goes to the jumper. And they both goes this way of this power supply to this board where the controller is. Okay, so let's hope it is good. Yeah, because this one is actually good, and the shorted one is this one, because it fits like this, and the shorted one is this one, which fits here. So I think it is okay. Okay, let's replace this Mosfet and hope everything works perfectly. This Mosfet is 16N60. 16N60. Let me find it. Okay, so here is a replacement Mosfet. Let's install it. Okay, so let's put it back to the board. Okay, so it is installed. Let's test again if we have short at the pressure rectifier. And we don't. So I think we are ready to test. We still have to replace the fuse. Let me replace the fuse. Okay, so the fuse is out. Let me clean the holes. The fuse is 6.3 amps, 250 volts. Let me bring one. Okay, so here is a replacement fuse, 6.3 amps. The fuse is good. The previous one was, blown. So I need to protect this one using heat shrink. Okay, so we are ready to test. Let's bring the test box. Okay, let's turn on. So it's on. We have 238 volts. So it's on, but the lamp did not flash at all. That means there is something else wrong. I think it's the controller IC is not working. It does not even charge the main capacitor. I'm afraid that the main capacitor is faulty. Okay, let's take it out again and check the big capacitor. Okay, the big capacitor has nothing at all. Let's check for short again at the bridge rectifier. It's not shorted. The fuse is good. So why it's not working? If we test from this line up to here and up to the fuse, it is good. And this one up to here and up to the neutral wire, which is this one. Yeah, this is good. I want to turn it on again and test the voltage at the big capacitor and see if we have anything there. I'm afraid that something will short out. No, I think we are good now. Let me connect the power cord. Okay, so let's turn on. So it's on and the lamp did not flash at all. If we test the big capacitor, we have 334, which is right. If we test the green wire to the black leads, we have nothing. No, we have 4.3, so it's actually working. 4.3 volts, the standby voltage is present. Why the lamp did not flash at all? I don't know why. I'm afraid that the big capacitor is not good. Let's try and short the wires, the green and the black wire. Okay, let me put the wires here, the brown wires. Okay, it works. It works good, but the lamp illuminates fully when we short the black wire to the green wire. I think this is because of the big capacitor. I want to check the big capacitor. Okay, let's disconnect. The big capacitor have 270. It actually looks good. It's still charged. That means it is good. Why the lamp flashes when we turn it on, like it's drawing current, while nothing is connected to its output? I'm afraid if we connect it directly to the mains, it will explode. Okay, let's try again. This time the lamp flashed a little bit, which is good. If we short, let me put the multimeter leads again here. Okay, let's short the green and the black wire. And now we are good. The lamp is not illuminating at all. Everything seems to be good now. Okay, let's put it back together. Okay, so it's back together. Let's turn it on. Okay, this is a good sign. It didn't do this at the first time. I don't know why. Okay, if we put the multimeter leads here and short the green wire to the black. Okay, it is working. I want to try it directly to the mains. Now we are at 200 watt lamp. We are at 200 watts. Let's turn on. It's still good. Nothing exploded. And if we go to directly to the mains, yeah, it's still good. Let's try it while it's connected directly to the mains. And yeah, it is working perfectly. Okay, so both power supplies are now fixed. And we saved 2 power supplies. This one and this one. Let me put it back together. Okay, so yeah, both power supplies are now fixed. I hope you enjoyed this repair. If you do, please don't forget to like, share and subscribe to my channel. Thank you for watching and see you in another video.